Good morning, students. Chapter 5, Magnetism and Matter. Yes, in last lecture we have discussed about Earth behaves as magnet. Why it behaves as magnet? What is reason? What is dynamo effect? We have discussed in last lecture. Okay, yes. Today we will see Earth's magnetism, magnetic elements of Earth. But before that, see. Earth. Okay, yes, Earth. We know that at each and every point, longitude circle indicates geographic north and geographic south. Yes or no? Longitude circle at a point. Longitude circle at a point. Okay. At a point indicates geographic north and south at that point. Yes, we know this. Okay, so yes, one imaginary plane passing from this longitude circle, one imaginary plane passing from this longitude circle, which indicates geographic north and south, is called geographical meridian. See, it is axis of rotation. It is geographical north. It is geographical south. Yes or no? Yes. So here longitude circle, it is like this. Yes, it is like this. It is longitude circle like this. Okay, it is longitude circle which indicates geographic north and geographic south. So one imaginary plane passing from geographic axis, you can say geographic axis, or from geographic north and geographic south is called geographic meridian. Okay, so yes, one imaginary plane passing from geographic axis, or we can say geographic north and geographic south is called geographic meridian. Meridian, it means one type of plane. It is one type of plane. So yes, it is geographic meridian. Clear about this? Yes, it is geographic meridian. Okay? Yes. Now we know that. Okay. It is called axis of rotation. Okay, now we know that Earth behaves as magnet. So we can compare that with hypothetical magnetic needle, hypothetical magnetic dipole. We can compare Earth's magnet as one hypothetical magnetic dipole, and its axis, we know that it is not coinciding with axis of rotation. But it is tilted. By 11.3 degree. Yes, we have discussed in last lecture. So this line is magnetic axis. This line, it is magnetic axis. Yes or no? Yes, it is. So now we know that if we take a magnetic needle free to rotate in horizontal plane, suspended, okay, then it will align in direction of magnetic field. And we have discussed in last lecture in a point that magnetic needle aligns in the direction of magnetic field. So yes, when we take one magnetic needle free to rotate in horizontal plane, it will needle always aligned in direction of Earth's magnetic field. In direction of Earth's magnetic field. And yes, it aligns in this direction, along this axis. Along this axis. Yes or no? Yes. Okay. So it is called magnetic axis. Magnetic axis. Similarly, imaginary plane passing from geographic axis, that is from geographic north and geographic south, is called magnetic meridian. We know that yes, it is magnetic north and it is magnetic south. Yes or no? Magnetic north and magnetic south. So again, one imaginary surface, one imaginary plane passing from magnetic axis. One imaginary plane passing from magnetic axis is called magnetic meridian, or imaginary plane passing from magnetic north and magnetic south is called magnetic meridian. So a similar definition. See, imaginary plane passing from magnetic axis, magnetic axis, or I can write in bracket, yes, magnetic north and magnetic south is called magnetic meridian, is called magnetic meridian, is called magnetic meridian. Clear about this? Clear about this? So yes, this points you have to remember. Okay, it is called geographic meridian, it is called magnetic meridian. Geographic meridian and magnetic meridian. Yes, if you have one magnetic needle, then that magnetic needle always it is aligned in magnetic meridian. Okay, it is always aligned in magnetic meridian. Magnetic needle always aligns in magnetic meridian. Clear about this? So yes, these points you have to remember. Now see, here it is. It is magnetic meridian which is passing from, it is geographic meridian which is passing from geographical axis. Yes, a plane perpendicular to geographical axis. A plane perpendicular to geographical axis like this. It is called geographical equator. Is called geographical equator. Is called geographic equator. Okay, and similarly, a plane which is perpendicular to this magnetic axis, it is called magnetic equator. This plane, see, it is magnetic axis. So one plane normal to it is called magnetic equator. It is called magnetic. So yes, you have to remember this each and every point. Okay, geographical north, geographical south, axis passing from it, geographical axis or axis of rotation, plane passing from it, geographical meridian. Earth behaves as magnet. Its magnetic axis is not coinciding with geographical axis. It is tilted by 11.3 degree. So yes, it is this. At two poles, it will coincide with Earth. It is called magnetic north. It is called magnetic south. Plane passing from these two poles. It is called magnetic meridian. And yes, magnetic needle always aligns in magnetic meridian. Clear about this? Clear about this each and every point? Okay. So now, first point: magnetic elements of Earth. Magnetic elements of Earth. First point we will discuss angle of declination. Angle of declination. What is angle of declination? See here. It is geographical north. It is geographical south. If I have one needle, if I I have one needle which is free to rotate in horizontal plane, this type of needle, then we know that it always aligns in north and south direction. It always aligns in north and south direction. But see, magnetic needle always aligns in magnetic meridian. Always aligns in magnetic meridian. Is magnetic meridian coinciding with geographical meridian? No. So whenever we have one magnetic needle, that magnetic needle will align like this. That magnetic needle will align like this. That magnetic needle will align like this. Okay? Yes. In direction of magnetic field of Earth. In direction of magnetic field of Earth. And yes, it is nothing but magnetic north and magnetic south. Magnetic north and magnetic south. So yes, it is true north. We can say it is true. It is true north. It is true north and it is true south. But whenever we have a magnetic needle, that magnetic needle will not align in direction of true north and south direction. It will align always in magnetic meridian. And magnetic meridian is different from that geographical meridian. Clear about this? So yes, from this figure we can say, okay, here this magnetic needle makes some angle with this true north. Magnetic north makes some angle with true north, and angle between them is called angle of declination. Angle between them is called angle of declination. Yes, we can write a definition. Okay, first, angle between geographical north and magnetic north, it is called angle of declination. Also, see, what is imaginary plane passing from geographical north and geographical south? Geographical meridian. What is plane passing from magnetic north and magnetic south? Magnetic meridian. So what is second definition? Angle between geographical meridian and magnetic meridian, it is called angle of declination. Angle of declination. Clear about this? Okay. What is meaning of declination? Simple. It is not in true north and true south. It is tilted by some amount. It is tilted by some amount, and that tilt, that angle is called declination. It is called declination. Clear about this? So how to write its definition? How to write its definition? See, angle between NG, that is geographical north, and NM, that is magnetic north. Angle between geographical north and magnetic north is called angle of declination. Is called angle of declination. Or another definition, yes, plane passing from these two poles is called geographical meridian. From this to it is called magnetic meridian. So angle between geographical meridian and magnetic meridian is called angle of declination. Is called angle of declination. Clear about this? Okay. So yes, what is angle of declination? You have to remember these two definitions. Yes, you have to remember these two definitions. Clear about this? Okay. So again, angle of declination, it is not necessary that this needle always aligns in true north and south. It is tilted by some amount. It is tilted by some amount like this. Okay, so this is called declination. In India, yes, value of declination is small. Value of declination is small. So yes, in India, if we place magnetic needle free to rotate in horizontal plane, it will indicate indicate true north and south direction, because in India declination's value is small. In India value of declination is small. So in India, if you place magnetic needle free to rotate in horizontal plane, it will indicate true north and south direction. Clear about this? Yes. This angle is with true north and true south. With true north and true south. Clear about this? Now second element that is deep angle. That is deep angle. Yes, it is called declination. Deep angle, it is also called inclination. It is also called inclination. Now what is meaning of inclination? See, I have this chalk like this. So yes, you can say, sir, this chalk is horizontal. Horizontal means what is angle made with horizontal? What is angle made with horizontal? It is 0. Now, is it horizontal? No, it is tilted with horizontal. It is tilted with horizontal. Means it is inclined with horizontal. It is inclined with horizontal. So yes, this is called inclination. It is called inclination. When magnetic needle makes some angle up or down with horizontal, it is called angle of D or inclination angle. Inclination angle. Clear about this? For example, it is horizontal direction. It is horizontal direction. Yes or no? It is horizontal direction. Okay. If first case, magnetic needle like this, magnetic needle aligns like this. Yes or no? So yes, here magnetic needle aligns in horizontal direction. Second figure, see, second figure, magnetic needle like this. Now, is this magnetic needle in horizontal plane? No, it is not in horizontal plane. No, it is not in horizontal plane. Also like this. Also like this. Okay. See? Yes or no? Do you understand about these three figures? 1, 2, and 3. 1, 2, and 3. Okay. If we have a magnetic needle free to rotate or it is suspended freely in Earth's magnetism, okay, then yes, it may be 1, 2, or 3. These three cases are possible. These three cases are possible. See, in first case, this magnetic needle is in horizontal direction. This magnetic needle is in horizontal direction. Here, this magnetic needle means magnetic field. Magnetic field makes some angle with horizontal. Here also, this magnetic needle means magnetic field makes some angle with horizontal. Makes some angle with horizontal. So yes, angle made by magnetic field with horizontal is called deep angle. Is called deep angle. Clear about this? So yes, angle made by magnetic needle. Angle made by magnetic needle. Magnetic needle means magnetic field. Because magnetic needle aligns in direction of magnetic field with horizontal is called deep angle. Is called deep angle, and this deep angle is denoted by phi. And this deep angle is denoted by phi. Okay, angle made by magnetic needle up or down. Up or down with horizontal is called deep angle, and it is called phi, and it is called, clear about this? Clear about this? So yes, it is one important topic. Okay, what is deep angle? Deep angle is angle made by magnetic needle with horizontal. See, for example, this magnetic needle is placed like this. So what is deep angle? 0. If it is tilted like that, then means it has some magnetic deep angle. It has some deep angle. Clear about this? And this deep angle depends on magnetic field at that point. It depends on magnetic field at that point. Now we will discuss, okay, for Earth at different points, that is on equator and on poles, what is deep angle? What is deep angle? Okay, we will see. Now we will understand deep angle with the help of bar magnet. See, if it is bar magnet, North Pole, South Pole. Yes, we know that magnetic field lines. North Pole outside, South Pole in. Yes or no? Yes, like this. And another magnetic field line, yes, it is like this. Here also magnetic field line, yes, it is like this. Okay? From North Pole outside, South Pole inside. Yes or no? Yes. See, here, if I am taking magnetic needle on axis of magnet, then yes, we know that magnetic dipole aligns in direction of magnetic field. Magnetic dipole aligns in direction of magnetic field. So here, if I place magnetic needle on axis, yes, at this point, so yes, it will align in direction of magnetic field. It will align in direction of magnetic field. Yes or no? Yes, it is. So see, here it is horizontal. It is horizontal. Yes or no? Yes. If at this point, for example, at this point, what is direction of magnetic field? Yes, direction of magnetic field, it is in this direction. Yes or no? So if at this point, if I place magnetic needle, that magnetic needle will align. That magnetic needle will align like this. That magnetic needle will align like this. Clear? Is this magnetic needle in horizontal direction? No. Is this magnetic needle in horizontal direction? No. Clear about this? Clear about this? Okay. Now, at this point, if I am taking magnetic needle, then yes, this magnetic needle, at this point, magnetic field, it is in this direction. Magnetic field, it is in this direction. So obviously, magnetic needle will align like this. Magnetic needle will align like this. Yes or no? Magnetic needle will align like this. Clear? So what is angle made by magnetic needle at this point? What is angle made by magnetic needle at this point? It is with horizontal. So here deep angle is 0. At this pole, situation is different. At this pole, situation is different. See, at this pole, situation is different. First of all, we will think about these two cases. On equator, magnetic field is in direction of tangent. Magnetic needle will align in this direction. Yes or no? Magnetic needle will align in this direction. Okay. So yes, in this case, magnetic needle aligns in this direction, means with horizontal, it do not make any angle. While in this case, magnetic field is in this direction, and with horizontal, it makes some angle. Okay, clear about this? So yes, on equator, needle is horizontal. Okay, and needle is in horizontal direction, so therefore on equator deep angle is 0. Angle of deep phi is equal to 0. While on poles, needle becomes vertical. Yes or no? How? See, here it is aligned like this. As it comes to this point, see, here it is in horizontal direction. At this point, it will be in direction of tangent, 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 and in direction of tangent. So at poles, magnetic needle will align like this. At poles, magnetic needle will align like this. At poles, magnetic needle will align like this. So at poles, what is angle of lead? Angle of lead phi is equal to 90. Angle of lead phi is equal to, it is 90. Clear about this? So yes, you have to remember these points. Clear about this? So yes, it is about deep angle. Now third one. is horizontal component of Earth's magnetic field. Is horizontal component of Earth's magnetic field. See, third one, horizontal component of magnetic field, of magnetic field. See, give me one answer. This magnetic field is in horizontal direction. Is this magnetic field in horizontal direction? No. This magnetic field is not in horizontal direction. So we have to resolve this magnetic field in two components. One in horizontal direction and one in vertical direction. Yes or no? One in horizontal direction and one in vertical direction. Yes, it is for bar magnet. Now we will see the situation for Earth's magnetism. So see, horizontal component of magnetic field of Earth. Magnetic field of Earth. Clear about this? See, here it is. I am taking two planes. It is one imaginary plane. P, Q, R, S. Yes, this P, Q, R, S plane is magnetic meridian. It is magnetic meridian. Okay, another plane like this. PQRS, that is T and it is U. So PTUS, another plane, that is PTUS. It is geographical meridian. It is geographic meridian. Okay, yes, we have discussed first case. What is angle of declination? Angle of declination means we know that magnetic axis and axis of rotation, they are not same, they are not coinciding, but they are at some angle. So obviously magnetic meridian and geographical meridian, they are at some angle, and angle between them is called declination T. Yes or no? This PQRS is magnetic meridian. Yes, again, PQRS magnetic meridian, PTUS geographic meridian. Yes, magnetic needle free to rotate in horizontal plane which is suspended always aligns in magnetic meridian. So yes, if I have one needle, then that needle will align like this. Okay, so yes, needle will align like this. Means it is direction of magnetic field of Earth. It is direction of magnetic field of Earth. Clear about this? So yes, magnetic needle aligns in magnetic meridian. And see, we have considered one general case when it makes some angle with, see, it is horizontal direction. And it is vertical direction. So see, this magnetic field makes some angle with horizontal, and we know that angle is called angle of T. Clear about this? Yes or no? So yes, what is horizontal component of Earth's magnetic field? If I resolve this magnetic field in two components, one component in horizontal direction and another component in vertical direction. So yes, this component of magnetic field which is in horizontal direction, it is called BH. This component of magnetic field which is in vertical direction, it is called BB. So yes, resolve this magnetic field in two components of magnetic field. First, BH, horizontal component horizontal component, and second BV, that is vertical component, that is vertical component. Okay, now from figure we can easily write BH. This B makes angle phi with BH, so obviously BH is equal to it is B cos phi, while BV, this BV is equal to it is B sin phi. It is B sin phi. Clear about this? Clear about this? Okay, so yes, BH and BV. Okay, now see, it is magnetic field of Earth. It emerges from geographic south and enters to geographic north. Magnetic field line of Earth is from geographical south to geographical north. Geographical south to geographical north. So yes, this horizontal component of magnetic field, it is towards, or it is in direction of magnetic north. It is towards magnetic north. Again, first case, Earth behaves as magnetic field lines emerges from geographical south and enters in geographical north. That we have discussed in first lecture. Okay, in last lecture we have discussed, okay, yes, it emerges from southern pole and enters in north pole. So yes, this horizontal magnetic field, it is towards north pole, while this vertical magnetic field is vertical below means towards center. It is towards center. See how? Like this. If it is magnetic field like this, then I can resolve this in two components. It is B. This component is called, this component is called B cos phi, and it is called B sin phi. It is horizontal component and it is vertical component. This horizontal component is towards magnetic north. This vertical component is towards center. Okay, now this situation is actually like this. Okay, because it is north direction, it is south direction. So magnetic field is along south pole to north pole. So like this. Okay, so this magnetic horizontal component of Earth's magnetic field, it is always towards magnetic north. Okay, and this vertical component is always towards center. Clear about this? So yes, you have to remember BH is equal to B cos phi, BV is equal to B sin phi. Now, if I am taking square and I add this to equation, BH square plus BV square, then I can write it is B square cos square phi plus B square sin square phi. Okay, so yes, BH square plus BV square, B square common, here it is cos square phi plus sin square phi. Cos square theta plus sin square theta is equal to 1. So cos square phi plus sin square phi is also 1. So yes, B square is equal to it is BH square plus BV square. So B is equal to under root BH square plus BV square. You have to remember this equation. Also, if I take ratio of these two equations, that is B sin phi upon B cos phi is equal to B sin phi means it is BV and B cos phi means it is BH. B cut, then tan phi is equal to it is BV upon BH, and therefore phi is equal to tan inverse BV upon BH, and it is called true deep angle. It is called true deep angle. Why true deep angle? Because magnetic needle aligns in magnetic meridian. True deep angle in magnetic meridian. Clear about this? So yes, this point you have to remember. Yes, this point is again important. Horizontal component of magnetic field of Earth. Yes, that horizontal component of magnetic field, it is towards magnetic north, because magnetic field lines of Earth starting from north pole, south pole to north pole. Clear about this? So yes, again this case is important. We will solve some questions based on this.